So you got word problems. Here we go. So it says a student scores a 72 out of 100 on a test. And if the maximum score on the test is also, on the next test, is also 100 points, what score does the student need to maintain an average of at least an 82? Now let's think about an average. So if you got the first test and he got a 72, and you got the second test and we don't know what it is, but how would you figure out the average? Well, what you would do is you would take these two tests, you would add them together, and then you would divide by 2 because there are two tests, and that would give you your average. Now we're looking for something that is at least an 82. So we want something to be equal to 82 or greater than 82. So it's going to be greater than or equal to 82. So that's kind of the way I'm thinking about the formula. In fact, that's practically the formula, which is going to be 72 plus x divided by 2 is greater than or equal to 82. So how am I going to solve this inequality? Well, the first thing I'm going to do is multiply both sides by 2 over 1. And when I multiply by 2 over 1, I get 2 divided by 2 right here, so that's 1. So the left side becomes 72 plus x, and the right side becomes 164. The symbol doesn't change because I didn't multiply by a negative. I multiplied by a positive, so the symbol stays the same. And now I want to get that x all by itself, and this 72 is a positive 72, so I'm going to subtract 72 from both sides, and so this right here ends up being 0, so I end up with x is greater than or equal to, and then I have to subtract, and I get 92. So that tells us that on the next test, that student must get a 92 or higher in order to have an average of 82. That kind of makes sense. All right, so this is a doozy. So we've got a parking lot in a student parking lot costs $2 for the first half hour, and then it costs $1.50 for each hour after that. And then if you squeech over an hour, any partial hour counts as an additional full hour. And so what is the longest time that a student can park in this lot if that student only has $7? Well, the first thing I like to do is I like to draw the picture. So let's draw what this problem looks like to me. So first thing I'm going to do is I'm going to draw, there's my half hour right there. So that's $2 for the half hour. And then I'm going to draw, here is $1.50 for a full hour. Here is $1.50, oops, I want to do that in red, is $1.50 for a full hour. And here is $1.50 for a full hour. And I'm just going to keep going, adding $1.50s, $1.50s, $1.50s until I get to that last $1.50. Now the idea is I've just drawn way too many $1.50s because we're only supposed to go up to $7. But I wanted to prove a point here. So if this was 1 hour, 2 hours, 3 hours, and if we stayed for 3 hours, what would we do? Well, we would do $1.50 times 3 plus the extra 2. What if we stayed for 4 hours? Well, we would do $1.50 times 4 plus 2. All right. But we don't know how many hours we're going to stay, so I'm going to call it X. That's what the whole point of this ... is. We don't know how many hours that is. So it's going to be $1.50 times X plus our extra $2 at the very beginning. And we need this amount to be less than or equal to $7. All right. And so we're going to subtract by 2. And that gives us $1.50x is less than or equal to 5. And now we're going to divide both sides by $1.50. Now when I divide both sides by $1.50, so obviously the left side, $1.50 divided by $1.50 is 1. So the left side is equal to x. The less than or greater than less than or equal symbol stays the same because we're dividing by a positive. Now I got to do 5 divided by 1.5. And I get, oh my goodness, I get 3.3333333. All right. Well, that's too many. That's too much because we can't pay for this extra hour. That would count as a full-on extra hour for 4 hours, right? So really, what we've discovered is we can only pay for 3 full hours plus the half hour at the beginning. So really, boy, I kind of coincidentally drew exactly the right answer, which is right here. This is the best we can do to spend something that is not more than the $7. And actually, we can do this in our head, can't we? So $2 plus $1 plus $1 plus $1. So that's $1, 2, 3, 4, $5. 50 and 50 equals $6 plus an extra 50 cents, so $6.50. So the best we can do is park for 3.5 hours, and that would spend $6.50, and we'd have an extra 50 cents to, I don't know, what would you do to buy bubble gum or something? So that answer ends up being 3.5 hours is how much parking we can afford. And that wraps up this very wonderful video.